Hi everyone, this is my first video, and in this video we shall learn about sinusoidal wave equation and we shall derive the time independent Schrodinger wave equation. If you consider a particle which is moving in to and fro direction about the mean position, that moment of the material is called a simple motion, or else in a very simple way we can call it as SHM. That's nothing but simple harmonic motion. In similar way, if the projection of a particle is performing a uniform circular motion on a circumference of a circle, here the moment of the particle is periodic. Suppose if the particle is started over here, it moves all the way on the circumference and again comes to its original position, again it continues its motion. Means the moment of the particle on the circumference of this circle is periodic. Such kind of motion is also called as simple harmonic motion. And here we shall consider a progressive wave which is passing on a given point in the medium that oscillate or vibrate about the mean position. Okay, and you can observe the moment of the wave. This is the half wave and this is one complete wave, and from here onwards again the generation of the wave is continuous. Means the moment of the wave is so periodic in this wave. That means this also undergoing, or this also a very best example for simple harmonic motion. Mean here we are expressing the wave and that wave is exhibiting the simple harmonic motion, hence we can call that wave as simple harmonic wave. Since the wave is expressed in sine function as a function of sine, we can call that simple harmonic wave as sinusoidal wave. That is the actual definition for sinusoidal wave. And here this sinusoidal disturbance is originating from the point O, moving in a positive x direction with a velocity v. Okay, and after every definite interval of time t, the progression of the wave is so continuous and so periodic, right? At the intervals say 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here we can observe that the wave which is generating from O is actually a vertical displacement from the mean position. See, so it all the way goes to this position. So let us take as +1 and again is coming back to the down till -1 and again it's going back to the mean position, again proceeding to certain height and again coming back to mean position, again coming down to certain depth, again it is going back to the mean position. Means the moment of the wave is so periodic, right? And as I told you, the wave is actually a vertical displacement from the mean position. And here, depending upon the energy, the wave may reaches to different heights, and the height up to which the wave is showing the oscillation or disturbance, that actually often called as A, nothing but amplitude of the wave. Okay, and the amplitude is actually the function of position. The amplitude of the wave is actually the function of position, that is x, and the time t. And the amplitude in terms of position and time can be expressed in a very simple way as psi of x comma t, where psi is called as wave function. And we can observe that as the wave is progressing, the wave is going to certain height at regular intervals of time. See, it is originated from O, went on to this height, that is to +1, again came to origin, that nothing but main position, again dumped to -1, going back to the main position, again it came to the same height, that is to +1. Means periodically the wave is developing or moving to certain constant height, right? And the development of the the movement of the wave to certain height is so periodic. In terms of the position, we can express, say, from here to here we can take as delta x, and this delta x actually gives information about lambda, that's nothing but wave length of the wave, right? And the amplitude of the wave, wavelength of the wave, velocity of the wave with respect to time can be simply expressed in the form of a simple mathematical expression as xi is equals to a sine omega t. This is actually called as sinusoidal wave equation, where xi, as earlier listed, called as wave function, and a is the amplitude and omega is the angular velocity, which is mathematically 2 pi nu, and this one t is time, right? And this psi is equals to a sine omega t, that what we call as sinusoidal wave equation, can be expressed in some other way that we shall see in this way. So as we have given, that is sinusoidal wave equation, xi is equals to a sine omega t, right? So and here as told, omega is the angular velocity, and the angular velocity can be given as omega is equals to 2 pi nu. But we knew that from quantum mechanical concepts, nu is equals to, it is the ratio of velocity to the wavelength, that is v by lambda, and t, it is the time period, and that can be expressed in terms of position or displacement and velocity as t is equals to x by v. We can introduce these two terms in the sinusoidal wave equation so that the equation will get turned into xi is equals to a sine 2 pi nu into t. And at the place of nu, we can write v by lambda, and at the place of t, we can write x by v. By introducing these two terms, the equation will get changed. Xi is equals to a sine 2 pi v by lambda, and at the place of t, we can write x by v. Here v and v will get cancelled, so that xi is equals to a sine 2 pi x by lambda. This is actually the required sinusoidal wave equation, which can be used for understanding many other factors, which will be actually used in deriving the Schrodinger wave equation also. And hope you can observe from this sinusoidal wave equation, it is possible to understand, it is possible to learn the periodic motion, the periodicity of the movement of the sinusoidal wave. And let us consider the same expression, that is the same wave that what we have given in the last minute, this one, the sinusoidal wave, which is moving in positive x direction starting from the origin O, and here the magnitude I have given 1, 2, 3, 4, 5, 6, 7 and 8, right? And here, from here to here, this is half wave, and from here again the wave will come over here, and that gives a complete wave. And as we told, the distance between this and this position will give the value of wavelength. Similarly, the distance between these two troughs also gives the value of wavelength, and this portion is actually the wavelength, right? So now we shall see xi is equals to a sine 2 pi x, nothing but position, right? Now let us consider half of the movement of the wave. The wave originated from O and all the way moved and reached this point where the position is, magnitude of the position is 2, which is exactly half of the wavelength, right? So that the equation 2 pi x by lambda, x is the position, right? And x is at here, this is the position of the wave, which is exactly half of the wavelength. That's nothing but x is equals to lambda by 2. We can introduce the same over here at the place of x. So 2 pi at the place of x, it will be lambda by 2, and the denominator we already have lambda. 2 lambda and lambda will get cancels, and now psi is equals to a sine pi. Pi is nothing but 180-degree rotation that we know. Sine 180 is, or sine pi is 0. Nothing but psi is equals to 0. That means the wave is not at above the mean position or below the mean position. Wave is actually at the mean position. That means xi is equals to 0 at this particular position. And then similarly, if you consider the second part of the wave, again means the wave is continuing from here and moves and will come over here, and this is the position right now, and here the magnitude of the position is 4. That means it given a complete wave, nothing but the position will give the value of its wavelength. Therefore x is equals to lambda, and we can introduce the same in the sinusoidal wave equation, so that xi is equals to a sine 2 pi. At the place of x, it is lambda by lambda. Lambda will get cancelled. Psi is equals to a sine 2 pi. And again, sine of 2 pi is again 0. That's nothing but psi is equals to 0. Means there is no amplitude for the wave because the wave is already at the mean position where xi is equals to 0. That means the equation which is proposed for the sinusoidal wave will clear-cutly explains the moment, the progression of the wave with respect to time, which is moving in a velocity v. And that's about sinusoidal wave equation. And now, with the help of this sinusoidal wave equation, now we shall try to derive a mathematical expression for the time independent Schrodinger wave equation. Time independent Schrodinger wave equation. For all the BSc students of all the different universities that comes across the India, this is the most important question in their examination, that is time independent Schrodinger wave equation. And now we shall look over how to derive this time independent Schrodinger wave equation. We are well aware that de Broglie and Heisenberg principles actually suggest that electrons are not an ordinary particle. They actually considered as waves. In particularly, de Broglie suggested that electrons are supposed to be called as matter waves, right? But one question will come to our mind, why actually this concept came? That is, why we are supposed to call the electrons as matter waves? The reason can be extracted by considering the concept of Sommerfeld theory. According to Sommerfeld theory, around the nucleus, though we are having a circular path, what you actually called as orbit or stationary state, Though the electron is present in the circular stationary state, the moment of electron is not restricted for circular motion. That means the electron is actually revolving around the nucleus in 3 dimensions. That means in x, in y, as well in z direction. That means the actual movement of the electron around the nucleus in its orbit is like this. This is the actual movement of the electron around the nucleus. You can observe that the moment of the electron around the nucleus is in phase, and the moment of the electron around the nucleus in its orbit is clear-cutly explaining the moment of electron around the nucleus is resembling the sinusoidal wave. Right. That's the reason why de Broglie used the term matter waves for the moving particle, the microparticles such as electrons. So de Broglie argued that though the electrons are considered as particles, since they are exhibiting the wave nature also, whatever the conditions we have applied for the sinusoidal wave, the same conditions we can use for the electrons also, and particularly for matter waves. So, in order to obtain a wave equation, Schrodinger used both de Broglie as well the sinusoidal wave equation to obtain the mathematical expression which helps in understanding the overall characteristic properties of a moving particle such as electron. And now we shall see how to derive the time-independent Schrodinger wave equation. And shall start by saying the notation set by both de Broglie and Heisenberg's, that is from de Broglie and Heisenberg's principle, from de Broglie and Heisenberg principles, we can conclude that, or we can say that electrons are not ordinary particles. Electrons are not ordinary particles. They are also waves. Simply called as matter waves. Right. So now we can use the sinusoidal wave equation in order to derive the wave equation. So from the sinusoidal wave equation, from the sinusoidal wave equation, that is xi is equals to a sine omega t. But we can write the sinusoidal wave equation in some other way, that is xi is equals to a sine 2 pi x by lambda, right? And shall consider this equation as equation number 1. Okay, now let us differentiate the above equation with respect to x, so that it will be d psi or else dou psi by dou x, that's equals to a, and the differentiation of sine will be cos. Differentiation of 2 pi x by lambda is, differentiation of a sine 2 pi x by lambda is a cos 2 pi x by lambda, and again differentiation of 2 pi x by lambda will be 2 pi by lambda. Now shall differentiate this equation again with respect to x. Differentiate with respect to x. So it gives a second order differential equation, that is dou square psi by dou x square, that's equals to a will remain and differentiation of cos 2 pi x by lambda will be minus sine 2 pi x by lambda, and we have already 2 pi by lambda, and again differentiation of 2 pi x by lambda will be, again we will be getting 2 pi by lambda, right? Now dou square psi by dou x square is equals to minus a sine 2 pi x by lambda. 2 pi by lambda into 2 pi by lambda, I can multiply this so that we will be getting 4 pi square by lambda square. But you can observe here we have a sine 2 pi x by lambda, that is nothing but psi. So from equation 1 we can say that psi is equals to a sine 2 pi x by lambda, and here we have a sine 2 pi x by lambda that can be written as psi. Right, so this can be given as dou square psi by dou x square, that's equals to minus psi into 4 pi square by lambda square. Or else we can convert this into dou square psi by dou x square, minus can be taken to the left hand side, so it will become plus, and 4 pi square psi by lambda square, that's equals to 0. Okay, and from here onwards we shall continue further. So we have the equation that is dou square psi by dou x square is equals to 4 pi square psi by lambda square is equals to 0. So let me write the equation, that is dou square psi by dou x square plus 4 pi square psi by lambda square, that's equals to 0. And let me take this as equation number 2. Since we are going with quantum mechanical approach, we are supposed to remove all the classical terms. That means here we have to remove the term lambda, and in order to remove the term lambda, again we have to take the help of de Broglie equation again. And we know the according to de Broglie equation from de Broglie hypothesis, from de Broglie hypothesis, that is lambda is equals to h by mv, where h is a Planck's constant, m is the mass of particle, and v is the velocity of the moving particle. Since we have lambda square over here, so lambda square will be equals to h square by m square v square. And let me consider this is equation number 3. Now let us substitute equation 3 in equation 2. Substitute 3 in 2, so that dou square psi by dou x square plus 4 pi square whole divided by, at the place of lambda square it will be h square, and m square v square will come to the numerator, and into psi, that's equals to 0. Right, and since we are discussing about a moving particle like electron which is revolving around the nucleus in a energy level, right, so that moving particle will obviously possess two energies, that is both potential energy and kinetic energy. So that if you want to know the total energy of the moving particle, that total energy, let me consider that as E. That total energy will be equals to sum of its kinetic energy and its potential energy. Let me write the potential energy as capital V. Okay, and now we know the expression for kinetic energy, that is E is equals to half mv square plus the potential energy term V. Now actually we need the value of V square, and here we have the V square. So we shall extract the value of V square, that is V square is equals to, V will come back to the left hand side, so it will be E minus V. 2 will be multiplied whole divided by m. This is actually the value of v square. Let me consider this as equation number 4 and this is equation number 5. Now, at the place of v square, we shall substitute the value of v square which is extracted from this expression that is given as equation number 5. That is, let us substitute equation number 5 in equation number 4. So that dou square psi by dou x square plus 4 pi square h square m square, at the place of v square it will be 2 into e minus v whole divided by m into psi is equals to 0, and here m and square will get cancel. So that dou square psi by dou x square plus 4 into 2 8 pi square 1 m have been left over here whole divided by h square into e minus v of psi is equals to 0. And this is actually the Schrodinger wave equation for a particle of mass m which is moving in one direction, that is along x direction. But since we said the moving particle, such as electron, which will be always revolving around the nucleus in all the 3 dimensions, so the one-dimensional expression what we have obtained for the moving particle can be extended to all the 3 dimensions, so that the equation can be written as dou square psi by dou x square for x axis and dou square psi by dou y square for y axis, dou square psi by dou z square for z axis, and 8 pi square m by h square into e minus v of psi is equals to 0. This is actually the Schrodinger wave equation which for a particle moving in 3 dimensions. Okay, but here we are well aware that h is actually, the value of h by 2 pi can be simply written as h cross. So by introducing this h cross in the above equation, we can write it as dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus here 1 h by 2 pi is equals to h cross, and here we have h by 2 pi, h by 2 pi, and again we living with 2. So 2 m by h cross square into e minus v of psi is equals to 0. And this is the finalized mathematical expression for time independent Schrodinger wave equation. By solving this Schrodinger wave equation, we can obtain the valuable information regarding the moving particles like electrons, atoms, and everything. And that's about the sinusoidal wave equation and the derivation of Schrodinger wave equation. And if you feel my video is useful for you people, please like it, share it, and comment it, and subscribe my channel to get the any notification and whatever the videos I post. Thank you.